Okay, arc heating. So whenever high voltage is applied between two electrodes, okay, uh, these two electrodes are separated with each other with some air gap. Okay, so when sufficient high voltage is applied between these two electrodes which have been separated with some air gap, the air becomes ionized and the air will start to conduct, okay, in the form of continuous spark or arc, okay, thereby producing intense heat. Okay, so you can see here in this image, okay, so these two are the electrodes, okay. So when I give a high voltage across these two electrodes, the air gets ionized and air starts to conduct and an arc is struck between these two electrodes. So the high voltage required for striking the arc, it can be obtained by using a step-up transformer. You can see a transformer here. You can by using a step-up transformer fed from a variable AC supply. Okay, so when voltage is applied between these two electrodes, which are separated by small distance, okay, so when high voltage is given to these two electrodes, what happens is at certain stage, okay, air gets ionized and air will act as a conducting material. Okay, air will act as conducting material. Air will start to conduct. Okay, so the electrodes which are used here, they can be made up of either carbon or graphite. Okay, and the temperature that is obtained is the when arc is struck between these two electrodes, the temperature that is obtained is in the range of 3000 degrees Celsius to 3500 degrees Celsius. Okay, so when current flows through these electrodes, a continuous spark appears between these two electrodes when sufficient high voltage is applied across these two electrodes with the help of a step-up transformer. Okay, a continuous spark will appear between these two electrodes. Give a name to that continuous spark as arc. What is arc? You might have already learned in your SGP subject. Okay, so this self-sustained discharge of electricity between two electrodes through air is known as electric arc. So the heating of a matter by an electric arc. Okay, so if I want to heat matter means if I want to heat any substance by this arc, because it produces enormous heat, this arc produces enormous heat, I can use that heat for heating some substance. Okay, so whenever I'm heating any substance by using electric arc, because of the arc which is struck between two electrodes, when high voltage is given to these electrodes, we will call it as electric arc heating. Okay, so why to waste heat energy produced, enormous heat energy produced by this arc, which is struck between these two electrodes because of the high voltage given to these electrodes. So that heat energy is utilized to heat some substance. Okay, so the substance that is to be heated, that can be heated by this arc, it can be a solid, liquid or gaseous substance. Okay, when the heating is direct, okay, so if I am directly able to means when the heating is direct means the material is directly placed in contact with the electrodes. Okay, so if the heating substance is directly placed in contact with the electrode, means that is known as direct heating. Okay, you can call it as direct arc heating. Okay, or if the substance that is to be heated is not in direct contact with the heating element, okay, then the heat is transferred to that substance either by convection or radiation. So if the heat is transferred to the substance by convection or radiation that is to be heated, then such sort of heating is known as indirect arc heating, similar to your resistance heating. Okay, similar to your resistance heating, here also In resistance also we have seen two types of heating methods: direct arc heating, direct resistance heating, and indirect resistance heating. Similarly here also direct arc heating and indirect arc heating. Okay, so direct the arc is will be in direct contact with the substance which is to be heated in the case of direct arc heating, and in indirect arc heating, heat will be radiated from the arc by convection or by radiation. Okay, so you can see a furnace uh, in which this is the substance which is being heated here. These are the electrodes which are being inserted here. Okay, so this you can see two electrodes here. So let us discuss different types of electrodes that are used in arc furnaces. Okay, so I hope you have understood what is meant by arc. Okay, so when arc is struck between two electrodes, enormous heat energy is produced. This heat energy we are going to utilize to heat the substance. Okay, any substance. Okay, what sort of substance arc heat? Arc heat, means the heat produced by the arc can be used to heat what sort of substance also I will tell you later on. Okay, initially let us see what are all the different types of electrodes that are used in arc furnaces. So you can see here on the screen, you can see three types: carbon electrodes, graphite electrodes, and self-baking electrodes. Okay, let us discuss one by one. So let us start with carbon electrode. Okay, so the carbon electrodes are made up of anthracite coal and coke. Okay, so anthracite coal means it is the coal made up which is very hard variety, and it contains relatively pure carbon and burns with a little flame and smoke. Okay, so these carbon electrodes are made up of anthracite coal and coke. Anthracite coal is a hard variety of coal that contains very pure carbon, and it burns with little flame and smoke. And coke is, it is a gray, hard and porous fuel. I think I have images here. I'm simply so coke is a gray, hard, and porous fuel with a hard carbon content and few impurities made by heating coal or oil in the absence of air. Okay, so this is anthracite coal and this is coke. Okay, so carbon electrodes are made up of anthracite coal and coke, and these carbon electrodes are cheap, and uniform heat can be obtained with large area of carbon electrodes. Okay, oxidation starts at around 400 degrees Celsius if you use carbon electrodes, and they are used in small furnaces. They are used in manufacturing of ferroalloys. I'm sorry, not ferroalloys. Okay, and for aluminium, and for calcium carbide and phosphorus. Okay, so the carbon electrodes are used for manufacturing of ferroalloys, aluminium, calcium carbide, and phosphorus. Okay, so this is our carbon electrode. After using whatever material, that is anthracite, coal, and coke, you can see these are the carbon electrodes which are used in the arc furnace. Okay, so next one is graphite electrode. Okay, so graphite electrodes are obtained by heating carbon electrodes to a very high temperature. Okay, so if the carbon electrodes are heated at very high temperature, then graphite electrodes are obtained. Owing to lower resistivity of graphite, that is one-fourth of the carbon, graphite is required half in size for the same current, resulting is easy replacement. Means it can replace the carbon electrode. Okay, because it's half of the size of carbon electrode is more than sufficient. Okay, as graphite electrode. So graphite electrode can replace the carbon electrode because its half size is more than sufficient for heating. Okay, and oxidation of this graphite electrode starts at 600 degrees Celsius. Okay, so you can see these are the graphite electrodes. Okay, so next is self-baking electrodes. So these electrodes, self-baking electrodes, comprises an outer casing made from an electrical conducting material and having inner radial and vertical ribs. Okay, so these self-baking electrodes. Okay, wait, I will show you the image. Okay, so they consist of outer casing made up of electrical conducting material, means outside electrical material is coated and they have an inner radial and vertical ribs. Okay, and carbonous unbaked paste is supplied to the casing, in which paste is being baked to a solid electrode by means of electric current supplied to the electrodes. Okay, so carbonous unbaked paste is taken. Okay, and this paste is baked to solid electrode by using electrical energy. Okay, so carbonous paste is taken and it is baked to a solid electrode. So this is the paste which is baked. Okay, they are made up of special paste. The composition of the paste depends upon the type of process for which it is employed. And when current is passed, heat is produced that bakes the paste to form an electrode. So, so these self-baking electrodes are used for production of ferroalloys, electrochemical furnaces, and in the production of aluminium by electrolytic process. So let us see different types of arc furnaces. Okay, so different types of arc furnaces are direct arc furnace and indirect arc furnace. So let us see how heating is produced in these furnaces in order to obtain the required temperature, desired temperature in this furnace. Okay, so let me show you an image. This is best. So in a direct electric arc furnace, the chamber of the furnace is lined with refractory material. Okay, the chamber, this is the chamber. This is the chamber. It is made up of refractory material. Okay, and arc is struck between the electrode and the charge. Okay, so charge means you know what is meant by charge. Charge is the substance which is to be heated, and you can see three electrodes here. Okay, so these are the electrodes. Okay, and this is the charge which is to be heated. Arc is struck between the electrode and the charge. Okay, as the arc is in direct contact with the charge and heat is also produced by current flowing through the charge itself, you can call it as direct arc furnace. So if the supply that we are using is DC supply or single phase AC supply, okay, if we are using DC supply or single phase AC supply, then two electrodes made up of carbon or graphite are sufficient. Okay, or it can even be self-baked. Okay. So if I am using three electrodes projecting from the top of the furnace, that means that the supply required is three-phase supply. Okay. So for if three-phase supply is given means you need three electrodes that are to be projected within the furnace from the top. Okay. The current passes through them via the charge, and since the arc is in direct contact with the charge, okay, this is the arc, you can see it here, it is glowing here. Okay, so electric arc, you can see here it is written electric arc. So since the arc is in direct contact with the charge, so it is possible to produce the highest temperature by direct arc furnace. Okay, so arc is in direct contact with the charge, so highest temperature can be produced. The most important feature of this direct arc furnace is that as the current flows through the charge, the steering action is inherent due to the electromagnetic force set up by the current. Okay, so when current is, since the electrodes are in direct contact with the charge, okay, So because of the electromagnetic force that is set up in the charge, because of the direct contact of the electrode with the charge, the electromagnetic force will be set up, hence steering action will take place. I hope you know what is meant by steering action. Okay, so steering action will take place on its own, so heat will be uniformly distributed throughout this charge. Okay. So this type of direct arc furnaces are used for manufacturing alloy steel, and it gives a purest product. Okay. So the arc which is struck between this electrode and the charge is having negative resistance characteristics. That means what? Resistance will fall with increase in the temperature. Okay. So therefore what will happen is some current limiting device is required in the circuit to prevent short circuit. It may be in the form of a reactor. Okay. So it is not shown here. Okay. So I have many images here. Okay, you can see the electrodes. This is our direct arc furnace. You can see the electrodes here. Okay. Uh, okay. So since arc has negative resistance characteristics, what will happen is the resistance of the arc will fall with increase in the temperature. Therefore, current limiting device is required to prevent the short circuit, and this device can be in the form of reactor. Okay. So this I have already told you. It is usually used for production of steel. Okay. And you can see here I have written here charge door. Okay. So a charging door is provided to this direct arc furnace. From here, charge is pushed into this chamber. Okay. So it is put into this chamber, we can say, instead of using the word push. Okay, so charge is put into this chamber through this charge door, and you can see here tapping spot is mentioned here. From here, as soon as the desired temperature is obtained, if the material substance is completely melted, okay, so from this tapping spot, it can be brought out. Okay, so you can see here. See, this is the tapping spot from where the molten metal is poured into this vessel in which the molten metal is collected. You can see on one more image. Okay, so this is the vessel in which this molten metal is to be poured. Okay, so it is poured here. Okay, this is the best image. Okay, so the usual size of this direct electric arc furnace will be around 5 to 10 tons capacity for melting 1 ton of steel. Okay, for melting 1 ton of steel, you need 1000 units of energy. Okay, electrical energy required is around 1000 units, and usually the capacity of this furnace will be around 5 to 10 tons. Okay, so I hope I was able to reach you people. And one more thing I wanted to tell you is that, see, so while melting the substance, okay, while melting the substance which is to be melted within this direct arc chamber or furnace, okay, what will happen is if there are any impurities, they will be accumulated at the top. Okay, impurities will accumulated at the top while heating. Okay, so this is the molten steel. You can see this yellow region is the slag. Okay, so the impurities will be accumulated at the top, that you will call it as slag. So through this spot, through the this spout, initially the slag will come out. Okay, after melting the substance. Okay, so the slag is taken out by some other vessel. Later on, the molten steel is collected in some other vessel. Okay, so there are some advantages of this direct arc um, heating furnace. Okay, it produces purest products when compared with other methods of heating, and it is very simple and easy to control. Okay, so there are some drawbacks also in this direct arc furnace. Drawback is that it is costlier, and it since it is consuming around 1000 units for producing 1 ton of molten steel. Okay, So the electrical energy, it's consuming more electrical energy. So electrical energy is expensive, even though it is used for both melting and refining. Okay. So applications are, these furnaces are used to produce steel, alloy steel, such as stainless steel. Okay. And they are used for manufacturing of gray iron casting. These are the applications. Okay, they are used for manufacturing of gray iron casting. Next furnace is indirect arc furnace. Okay, so this is it. This is our indirect arc furnace. So in this indirect arc furnace, if you see, if you observe the position of these electrodes, these are the electrodes. Okay, this black portion, rod-like structures, whatever you can see, are the electrodes. So in indirect arc furnace, okay, so these are the electrodes. Yeah, these are the electrodes. Okay, so these electrodes are placed horizontally within the furnace above the charge. Okay, so arc is, when supply is given to these electrodes, arc is struck between these two electrodes. Okay, when supply is given to these two electrodes, arc is struck between these two electrodes. Okay, so initially, these electrodes will be in contact with each other, okay, similar to your circuit breaker contacts. As soon as these contacts separate, okay, arc is struck between these two electrodes. In the case of indirect arc furnace, okay, it's not the case with the direct arc furnace, but in the case of indirect arc furnace, initially the contacts will be in contact with each other, and when these contacts move apart, arc is struck between these two contacts. Okay, and when arc is struck, definitely heat is produced. Okay, due to the arc which is struck between the air gap of these electrodes. Okay, and this heat produced will be radiated towards the charge. Towards the charge, the heat produced by this arc will be radiated towards this charge, purely due to convection and radiation. Okay, usually these furnaces are of a single phase type. Okay, so only two electrodes will be there, and since it is only of single phase type, means they will be smaller in size. They can, the supply that is given to this indirect arc furnace is single phase supply, hence their size will be small, and the amount of one phase load can only be taken by these furnaces. Okay. So furnace, this furnace usually it will be cylindrical in shape. It will be cylindrical. It is not looking like cylindrical, but it will be approximately cylindrical in shape. See, you can see here. They will be cylindrical in shape. Okay. And the arc will not come in contact with the charge in this furnace. So the automatic steering action which is present in direct arc furnace is absent. Okay, so in your direct arc furnace, there will be automatic steering action due to the electromagnetic field that is produced within the charge because of direct contact of the arc with the charge. But here, automatic steering action will not take place. Therefore, the furnace is to be rocked mechanically. You can observe there are wheels here. This is a wheel. This is also a wheel. On the other side also wheels will be there. So these are the wheels. You can see in this image, you can see the wheels. Okay, so these are the wheels. So because using these wheels, this indirect arc furnace is rocked. Okay, it is rotated. Okay, it is rocked. Rocking, to and fro movement. Okay, rocking means to and fro movement of this furnace will be there. Okay, so since in order to uniformly distribute the heat within the charge, you are rocking this furnace. Okay, you are rocking this furnace. Therefore, sometimes this indirect arc furnace is also called as rocking arc furnace. You can even call this furnace as rocking arc furnace. Okay. So, and you can see here electrodes are projected from both sides into the furnace on both from each end. okay, on the horizontal axis. Okay, so since during the process of heating, what will happen is these electrodes are consumed, means the electrodes are consumed means the length of the electrodes will be gradually decreasing. Okay, so the feeding of the electrodes from both sides must be continuously done. Okay, so we must make sure that the arc should not extinguish between these two electrodes. In order to avoid extinguishing of the arc between these two electrodes, okay, so the electrodes must be continuously fed from both sides. Okay, the electrodes must be continuously fed from both sides into the furnace. Okay, so the charge in this furnace is heated not only by the radiation from the arc between the electrode tips, but also by conduction from the heated refractory during rocking action. So due to rocking action, it is rocking, to and fro motion will be there of this whole furnace. Okay, so what will happen? The walls are absorbing the heat. Okay, refractory lining will be provided to these walls. So from the walls, this charge, when it comes in contact with the walls, it takes heat from the walls. Okay, the charge will be taking heat not only from the radiated heat from the electrodes or from the arc, it is also taking heat from the refractory lining of these walls. Okay. So the power input to the furnace is regulated by adjusting the arc length by moving the electrodes. So we can adjust the arc length by simply by moving the electrodes. So the temperature is lower than the direct arc furnace in this case. Okay. So the temperature developed within the furnace will be less when compared to direct arc furnace. So indirect arc furnace are suitable for melting metals having low melting points. Okay. So they are used for melting the metals which have low melting points, such as non-ferrous metals such as brass, copper, zinc, okay, etc. Okay, so usually for non-ferrous metals, if we want to heat the non-ferrous metals, if we want to melt the non-ferrous metals, indirect arc furnace is used. Okay, and this furnace can be equipped with an automatic rocking equipment in order to for to and fro motion of this furnace. Okay, so usually the power factor of will vary from zero point 0.7 to zero point 0.8, and the electrode material and the electrical equipment of the indirect arc furnace are similar to that of direct arc furnace. Okay, so the electrode material and electrical equipments that are used for this arc furnace will be same as direct arc furnace. So this is about the operation of this indirect arc furnace, and advantages of this arc furnace is that uh, it has lower overall production cost per ton of molten material. Okay, sound casting is thin and intricate design can be produced, means complex design can be produced, and metal losses due to oxidation, volatilization are quite low in this, and it is flexible in operation. These are all the advantages, and disadvantages are no inherent steering action, so there is no current flow through the charge. Okay, and continuous rocking should be done to distribute the heat uniformly. These two are the disadvantages, and applications are they are used for heating the non-ferrous materials. That's the only application. Okay, so this is about um, arc heating. Okay, so arc heating can be two types: direct arc heating and indirect arc heating. In direct arc heating, electrodes will be the arc will be in direct contact with the charge. In indirect arc heating, the heat is distributed to the charge by convection or radiation. Okay, so in direct arc heating, steering action will be automatic, whereas in indirect arc heating, steering action will not be there. So you need to rock it by using some rocking mechanism. Okay, so we'll discuss next another topic in the next class.